This video is about the section 6-7 in the textbook Product to Sum and Sum to Product formulas. It's a very, very short section, maybe just 2 pages long. Even though the section is short, the formulas have a long, interesting history. They were developed by astronomers in the 1500s. The reason is that there was need for faster ways to calculate navigation. Europeans had started migrating, if you will, to America in the 1500s after Columbus and all that. And then, for reference, Copernicus in about 1543 put out the theory of heliocentrism, which posited that the Earth revolved around the Sun. Copernicus, in his writings on heliocentrism, refers to an algorithm that's called prosophoresis. These astronomers had developed formulas, for example, the product to sum, which takes the product of two trig functions and equates it to the sum or difference of two trig functions. So here the product of two cosines is equal to the sum of two different cosines. The reason these formulas were useful is because the task of multiplying two numbers together, by hand on paper and pencil or whatever stuff they had, is tedious, long, and prone to error. However, the similar process of subtracting two numbers or adding two numbers is much, much less tedious and much less prone to error. Now, as it turns out, in the early 1600s, so somewhat later, logarithms were invented, and their utility is that the logarithm of a product is the sum of two logarithms. And so logarithms were used instead to convert multiplication to addition. Now these formulas are, of course, no longer used to convert multiplication to addition. However, they are used in theory, like calculus and physics, and so there is merit to knowing that these formulas exist. Notice the comment down here. These formulas do not have to be memorized. That's true. Instead, remember how they are derived, okay? Then when you want to use them, either look them up or derive them as needed. So in future courses, calculus and physics, you may need to use them. Now, you're not going to remember them exactly how they fit together, but if you remember that they're there, oh yeah, there are these product to sum formulas, then, in a situation where you need to use them, you say, oh, I know I can write this product as a sum or difference. So then you can go look the formulas up. If you have no inkling that the formulas were there in the first place, then you would have no idea to even go and look them up. Louis Pasteur, a French biologist, French microbiologist, said that chance prefers the prepared mind. So this section is preparing your mind. In the future, when you might need to apply these formulas in calculus or physics, you'll just say, oh, my mind is ready, I get it. I know that these formulas exist, let's go look them up and use them. If you don't know they're there, in other words, if your mind isn't prepared, then there's no way you're going to make that next step. A comment about these product to sum formulas: they really are just nothing more than a reorganizing of the facts from the sum and difference formulas that we did 2 sections back. Notice here that if you add these two together, then these terms drop out, and so it would be the sum of these two terms. Now these two terms are the same, so when you add these together you get 2 times this term. And then for dividing by 2, the sum of these divided by 2 is equal to that term right there. That would be this middle formula right there. Here's the second bank of formulas, the sum to product formulas. So sums over here, products over here, product. So what they are is they're just a clever backward reversing of the product to sum formulas. I encourage you to look up the Wikipedia page for this funny word, prosophoresis. It's from Greek words, prosthesis, to add, like a prosthetic device, and apophoresis, which is to subtract. So here's a photo of that Wikipedia page, which I hope you'll look up. So here's that funny word, and then here's the subtraction, right, and the addition that's referred to in the Greek etymology of the word.